Welcome to question 3 of the 2019 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. For question 3 we're told the only possible outcomes when a coin is tossed are a head or a tail. When an unbiased coin is tossed, the probability of tossing a head is the same as the probability of tossing a tail. Jo has 3 coins in her pocket. 2 are unbiased and 1 is a biased coin. And when the biased coin is tossed, the probability of tossing a head is 1/3. Jo randomly selects a coin from her pocket and tosses it. And for part A, we want to find the probability that she tosses a head. So I think the best way of approaching this question is to set up a tree diagram. So the first thing that we need to consider is whether she gets a biased or an unbiased die. So I'm going to let B be the biased coin, so she can either get a biased coin or she could get an unbiased coin, which is going to be B dash or B complement. Now, based on the fact that there's 2 unbiased coins and 1 biased coin, we can now note the probability of selecting either one of those kinds of coins. So for the biased coin, there's 1 out of 3, and for the unbiased coin, there's 2 out of 3 as its probability of being selected. Next, after Jo has selected a coin, she can either get a head or a tail. So for the biased coin, we know the probability of tossing a head is 1/3, and that means the probability of tossing a tail with that coin is 2/3. For the unbiased coin, there's a 50-50 chance of either of those outcomes occurring, so it's 1/2 and 1/2 on our tree diagram there. And now that we have that set up, we can answer the question, what is the probability that she tosses a head? So the probability that Jo will toss a head is going to equal, and to find the probability we need to look for all the pathways through this tree diagram that result in a head. So we could toss a biased coin and get a head, or we could toss an unbiased coin and get a head. So the probability becomes 1/3, which is the probability of getting a biased coin, multiplied by 1/3, which is the probability that the biased coin will result in a head. And then we need to add on to that the second branch of the tree diagram that we identified, which is the probability of selecting an unbiased coin, which is 2/3, multiplied by 1/2, which is the probability of getting a head with that particular coin. So next our job is just to evaluate that. So 1/3 times 1/3 is 1 on 9. And then we add on to that the second possible way of getting a head, and that is 2/3 times 1/2, which actually results in 1/3. But we can write that with a common denominator as being 3/9. So that means we can add those two together, and we find, therefore, the probability of obtaining a head when Jo selects a coin from her pocket and tosses it is equal to 4 divided by 9. So that is the answer to part A of this question. From the examiner's report, we can see that this question was reasonably well done, with almost 70% of students getting full marks for the question. And we can see that the examiner's solutions are essentially the same as what we did on the previous slide. They noted that this question was worth 2 marks, so appropriate working was required to be shown to get full marks for the question. The appropriate working could include computations, so the multiplication of the fractions, or even just showing a probability tree diagram with relevant branches clearly identified, so that could also count as working. And the last thing the examiners note is that in some situations it was not clear which fractions were being manipulated or how they were being manipulated. So just make sure that your working is really clear and easy for an examiner to work out what you're doing. For part B, we want to find the probability that she selected an unbiased coin given that she tossed a head. So this word given indicates that we're dealing with conditional probability. And that's because we know something about what has occurred. So the conditional probability formula is the probability of A given B has occurred is equal to the probability of A intersecting B divided by the probability of B. So that's just a general formula that you should know for conditional probability. So now we want to apply that to this question. So the question, if we can write it out in symbolic form, essentially asks what's the probability that she selects an unbiased coin, which I've used B dash to represent the unbiased coin in this tree diagram, given that she obtained a head. Now, based on our formula that I've just written up there in red, this becomes the probability of B complement, which is the unbiased coin, intersecting heads, divided by the probability of her obtaining a head, which we actually found in part A. So for the top line of our fraction, the probability of B complement, which is our unbiased coin intersecting a head, is this branch followed by this branch. So to work out its probability, we're going to do 2/3 multiplied by 1/2, and then we're going to divide that result by the answer to part A, which was 4 on 9, and that was the probability of obtaining a head. So now we multiply the fractions on the top line, and we get 2 times 1 divided by 3 times 2, which actually just works out to be 1/3. And then instead of dividing by 4 over 9, we're going to multiply by the reciprocal or flipped fraction. So we're going to multiply by 9 on 4, and that will equal 9 divided by 12, which can be simplified to give our final answer. So 9 divided by 12 is the same as 3 divided by 4. So that is the answer to part B of this question. From the examiner's report, we can see that just under 50% of students got this question correct, with most students correctly identifying the conditional nature of this probability problem. It was, however, noted that many students who did not simplify their answer to part A did not carry out the subsequent calculations successfully. So simplifying that fraction in part A aided the students in answering the second part of this question.